Hello everyone, this is Dr. Greg Campbell. I'd like to invite you to this nice webinar on the KATANA Zirconia block. We're going to go soup to nuts on everything for you to be able to use this starting immediately after you watch this webinar. So I'm going to take you through this. This is going to last approximately an hour, and I hope you find this as useful as I did when I was putting it together for you. So again, we're going to give you a new perspective in going from ordinary to extraordinary on using this fantastic block that's hit our market, and I use this daily in my practice, and I'm enjoying the benefits of this block greatly. So we're going to go through all that as well. So here we have KATANA, which is from Kuraray meets CEREC in the SpeedFire oven, which came out approximately a year and a half, 2 years ago at the Chicago Midwinter. So what we have is the ability to now have an aesthetic solution, chairside, for our patients. A little bit about me. I graduated from the University of Southern California. You guys can read this if you want. I've been very involved in testing products with Ivoclar, with Vita, also with Sirona. I'm a key opinion leader for many of the companies on here, and I really enjoy writing technique manuals on how to do the design and everything on here. And lately been developing the polishing kits for our silicates, for the zirconia, and also for our polyceramics. And in this video I'll also show you the pre-sintering zirconia polishing kit that I use to really make this KATANA stand out and pop. So outline for today is we're going to go over the introduction of the new block. I'm going to go basically in a little bit of detail what it's all about. And then we're going to go into CEREC and show you how to set up the case to use the KATANA block. We're going to then show the importance of insertion axis and model axis currently with the newest version, the 4.52, and how you really need to set your insertion axis for this polychromatic block. We're going to go through design details, milling protocol, post-milling protocol, which I think is important. I have a section here on troubleshooting, which I found to be it's incredibly valuable if you're a new user for this, or even a current user, of some of the things that you're going to find with some of the hiccups that have been reported to Sirona and are currently being worked out. And then at the end we're going to go over cement and bonding protocol for zirconia. And by the way, yes, you can bond to zirconia. So what do we need to sinter and mill with our system, our chairside system? Basically you need the most current version, which is CEREC version 4.52. You need the materials package update that came out just recently, and you're going to need to have a SpeedFire oven. Currently the only oven that's for chairside use approved has been with the SpeedFire oven. There's a lot of testing going on with other ovens, and as that comes out we'll certainly let you know what can be used. They prefer you to dry mill this, but you can do a wet mill as well, and on your wet milling you can do the milling instead of grinding if you have the modified left step motor. And certainly calling Patterson or Shine and running your serial number will help you to identify if you need to modify your left motor or if it's already been modified for you. Okay, so one of the things interesting about this oven, when it came out, it was designed to do the CEREC zirconia. It also there's the Vita zirconia and also the Ivoclar, but it has a special induction technology which does a rapid firing time or rapid induction of heat. It raises the temperature, or increases the temperature rapidly. In doing this, the KATANA, which needs time to get the translucency, we've figured out it needs a 30-minute sintering cycle to do KATANA to get it actually an aesthetic block, which I'm very excited about because, quite honestly, I've just never been impressed with the current zirconia blocks that are on the market. So now to have an aesthetic solution it's pretty exciting for me to use in my office. So the other thing about this oven is it's able to reach the higher temperatures that's needed for the KATANA. The KATANA requires a higher temperature to fire than the other zirconias that are currently on the market. So here's the workflow with KATANA. This is a common workflow that we use for most of our chairside materials. We're going to design and scan, we're going to mill, and then we're going to prepare that block to be sintered. After sintering, we can then polish and or glaze. So you're looking at timing, 15 minutes for milling. This product can be fast milled or it can be fine milled, and the sintering cycle is consistent irregardless of the shade that you pick. This is one big difference for you users, that you're used to picking, hey, I've got an A2 zirconia, I've got an A3.5, I've got a whatever, a B1, and the sintering time is modified in the system. With KATANA, they figured out that the one firing cycle for all their temperature, or I'm sorry, all their shades, is certainly the way to go for this product. So what makes this block different? Really, it comes down to how Kuraray sources their zirconia powders. And they've been using this in their industrial applications since 1983. It's a proprietary and it also has the proper light refraction. So it's a very different powder than what the other manufacturers that we currently have in our arena are using. So the powder actually comes out more translucent. So to get this, it requires a higher sintering temperature, and it reacts differently when it's sintered. And therefore, when it reacts differently, we're seeing more translucency and greater aesthetics than the competitors on the market. So we've got multi-layer blocks. The beautiful thing about this is that you can't see the gradation, but what they did on here is they did something really, really smart here. They patented their multi-layer technology. And just like the other polychromatic blocks or multi-layer blocks that we have in our armamentarium, you can increase or decrease chroma and translucency by positioning the restoration in the block. And I really like the fact that I can actually match the translucency on the adjacent teeth by positioning it. So it's a really wonderful block that we use and are getting some fantastic results. So here's what we're talking about here. We're looking at how it mimics a natural tooth. So these gradations, these 4 layers, the first layer, the enamel layer, is 35% of the block. The transition layer 1 and 2 are each 15%, and the final layer, the body, or the dentin layer, is 35%. Ironically, this really does mimic what a natural tooth looks like. So this is well thought out, and by positioning it, you can get more or less translucency, and therefore increasing or decreasing your chroma, which is very, very important. So here's some pre-polished and sintered, but not polished afterwards or glazed afterwards. These came right out of the SpeedFire oven as an A2C2 of both a molar as well as an incisor, central incisor, and just also showing the occlusal anatomy, which is absolutely excellent on this. I like that we're able to get better anatomy than our wet mill using the diamonds. Using these carbides, we're able to get some pretty terrific occlusal anatomy. We don't get that washed out buttery texture or buttery appearance that we've been accustomed to, and then having to add a lot of anatomy afterwards. So it's less work. It's saving you a little bit of time. Here's a case that I wanted to show you, talking about getting aesthetics. This was a patient that had a lot of cervical decay. We cut off that old restoration. We're able to do immediate dentinal sealing on that tooth, do a nice design proposal, fire this, and what I did is applied just glaze. I pre-polished this. I applied glaze only. I removed the glaze on any area that was touching the tissue, as well as my occlusal contact points, and we got a pretty good aesthetic outcome. You can actually see the chroma, you can see the gradation of the shade here, and you do have translucency built into these cusp tips based on how I position the block. If you look on the lower right-hand side there, where you see the block position, you can see that incisal translucency ring. You can also see the cervical ring. Keep in mind that this is done with a 12Z block. A lot of users in our arena, we're going to go over this in a few minutes, feel like they want to mill everything out of a 14. You're going to be able to do 95 to 99% of all your restorations in a 12Z block. So why are people choosing zirconia? I was really slow to the table on this because I just really was not happy with the aesthetics. I was happy with what I was seeing with the margins, but what we're seeing is more flexible and conservative preparations. And we also are seeing less reduction of tooth structure. This photo you see on the right is actually a zirconia restoration prep that I did. I kept this very high on the buckle. I did IDS, obviously you don't see IDS on that, but you're still seeing decay on there. And absolutely bonded this sucker in with a PANAVIA V5. It had a very good outcome and followed the IDS protocol as well. I'm seeing very precise milled margins, and I'm seeing, exactly what the manufacturer says. We're seeing higher flexural strength, and it's really important on the flexural strength because we're seeing a lot of manufacturers that are changing their numbers. They're doing biaxial testing instead of the 3-point bending test, and so when they're giving you these numbers, ask them for the ISO specs and make sure that you're comparing apples to apples with this. The other thing is it's easier to insert. I'm having less adjustments. And I'm finding that it seems to me that the CEREC software, probably since 4.3, maybe 4.4, was designed for the zirconia. We're always having to raise our fissures for the EMAX and for the other products. And on this one, I'm having very little adjustments. When I mill this and I center this, and I've tried it in the mouth for the first time, I mean, my margins and approximately are almost dead on, and my occlusal adjustments when I'm done, based on following the proper prep metrics as well as my parameters, are absolutely spot on, which is great. And I love the aesthetic option. You know that very much. Aesthetics are important. And now we're getting a stable bond to the zirconia, and I'm loving how the soft tissue is reacting to the polished zirconia. Okay, so here's what we've got. How many blocks do we have? What shades do we have? What they did, they, meaning Kuraray and Nataki, they sat down and they said, what are the most common shades used in the world? What do clinicians use the most? So what they said is, we're going to come up with 15 shades. So they matched 13 of the Vita shades. Then they came up with their NW, which is their bleaching shade, or natural white. And then they came out with another shade called CL. Okay, and the CL is actually a clear, and that really doesn't count as in a super translucent multi-layer, and I'll address that later with you. So they really have quite a great selection of all the shades I practically use in my office, and I love the fact that I have options. Okay, so the 12Z is going to be coming out. Currently the 12Z is out. The 14Z is going to be available in September of 2018, and they're stocking that up for you, so you're going to have the ability to have either choices here. But I will tell you that you're going to, again, as I mentioned a few minutes ago, the 12Z is going to take care of probably 95 to 99% of your cases. Okay, so we got the super translucent multi-layered zirconia. It comes in a basic kit with 5 shades, so you can try all the 5 shades, or you can get the sleeves like we're used to ordering, where if you want to order all A2s, you can get a sleeve of 5 A2s. So this is really, they're giving you a lot of options to try this material, and the packaging is pretty standard and easy like we're used to. You also have an intro to their natural, which is an A2, A3, which are the 2 most common shades that are done in the world. So if you say, well, I just want to try this, you can try a 2-block kit and mill out an A2 or an A3 to see how this works in your hands. Then they have the natural white and the B1 shade, again, to try those. So let's go into preparation guidelines. What I love about this is in the posterior, you just have to remember the number 1.0. 1.0 is important, 1 millimeter. And so we're looking for 1 millimeter reduction in here. And the only thing that on these guidelines that I really am a little bit in disagreement with is when we're talking about an inlay, when they're asking for the estimates to only be 1.0 millimeters. I believe that that's going to need to be a little bit wider and make sure you have your taper on there. So again, the same parameters. When you're using them for the ceramics, you want to avoid a J margin, the ski slope. You don't need to do a deep shoulder. Knife edge is actually not indicated through Kuraray and Nataki, but a lot of people are doing knife edge and feather. You don't want to have sharp transitions. So these are the same things that we've always learned in doing proper ceramic preparations. Just can do it with less reduction. And that's pretty exciting to me, that I can actually do a 1.0 reduction, have my cursory details at 1.0, and get a 1.0 restoration that's twice as strong as the leading competitor as far as maybe a lithium silicate or lithium disilicate. And because with those you need to get 1.2 to 1.3 to get 1.0, because you have to take into account your occlusal milling offset in our Chairside software. So you're doing 20% less reduction and you're getting 50% more strength. To me, I find that very, very exciting. And it's better for our patients. This is a diamond. This is that I use when I'm doing my reduction. This is actually a 2.0 reduction. It catches on the triangular ridges and transverse ridges when I'm doing my fissure reduction. So this is giving me the proper reduction of about 1.0 to 1.1. Now you can actually go to a 1.8, which is a different color stripe here, but this is through Meisinger. And this has just made my entering ceramics over the last 11 years so much easier and predictable, because the biggest problem we have is under reduction. And we have failures because of that under reduction in the fissure as well as the functioning cusp. This actually eliminates that from my worry in all ways. So I like this product quite a bit. So you can talk to your local rep about getting this and trying this and see how that works in your hands. Okay, prepping. We talked about 1.0, 1.5 occlusal reduction. The depth cut we were talking about to get our desired anatomy. You want to have a shaft for 0.8 to 1.0. In the anteriors, it's 0.8. For veneers, we're talking about 0.4. Yes, I did say veneers. You can actually do that with this product as well. The biggest mistake that I'm seeing as I travel around the country and talking to doctors and labs is we're not seeing the 2-plane reduction in the posterior. We're only seeing a 1-plane, and they're missing that 2nd plane as you're going from the abuccular lingual onto the occlusal surface. And therefore, it's very, very thin in that area, and you can actually have a failure of a ceramic if you're not doing the proper reduction. And of course, please note in the anterior we have 3 planes. We have 3 planes of reduction, not 2. So I just wanted to bring that to your attention. And that little note at the bottom about the occlusal milling offset turns off in zirconia. That's true of Kuraray and Nataki's Katana. It's true of the Vita. It's true of the Ivoclar. It's true of the 3M. The occlusal milling offset turns off when zirconia is being done on our Chairside or in our Chairside software. So if you have a 1.0 millimeter fissure, you're going to get a 1.0 millimeter crown in its depth, which I really am very, very happy to see that. So we talk about a chamfer or shoulder as the preferred margin from Kuraray Nertaki. This allows for a more accurate mill of the pre-sintered zirconia. And then when using a knife edge or feather margin, which they're not recommending, but a lot of people are using this in private practice and in their offices. And if you're doing that, you just got to keep in mind that you run a higher risk of chipping when you're milling, and you certainly in no way, shape, or form should fast mill this when you have a feather edge or knife edge margin. All right, so here's another case that we did. This is one of the very first cases. I apologize for that blurry image up there. I need to replace that. I just saw that. But we can get some pretty good aesthetic outcomes based on where we started on the upper left area and then where we finished on the bottom of the screen here. I love the ability that I can position this block and I can get the aesthetics to match the adjacent teeth and have great function for our patients. Again, here's some more cases that we have here. This is a fun case to do here where I just glazed only, pre-polished it, and got a pretty decent outcome. The patient was very, very happy about this. Obviously removed the staining on that teeth as well. So it's nice to go back, take a look at these, and you can definitely get it. It doesn't look opacious. These blocks tend to run a little high in value, and so therefore what I'm doing in my office is if I want an A2 desired outcome, I'm milling an A3. So I'm shade shifting one shade to the right. Okay, so here's that case I started out with earlier today. I was showing you that I prepped that for zirconia. I kept it very high. I was able to achieve some pretty nice aesthetics. I did characterize this to try to match all the white on the adjacent teeth. And again, the patient was ecstatic that they were able to walk out the same day and have something very, very conservative done that's going to last an incredibly long time in their mouth. The margins on this were just exceptional. So let's go forward here. This is just another case there. So there's a new kit on the block. You know, we're talking about pre-polished and sintered only. Again, we can get these are what I'm getting out of the SpeedFire oven. This is what it looks like. I have very little work to do on this. I could technically just polish it. I'm going to take a few seconds to do that on very low RPM, going no higher than 4,000 RPM and very light pressure. If you stay in one area too long, it's going to pearl. And if you pearl, you just need to sandblast the surface, and that will take care of the pearl, and you can repolish. Okay. So let's get started with CEREC. How do we do this? How do we use the new KATANA STML block chairside? So what I want to do is I'm going to walk you through a case from soup to nuts on this, how we're going to do this, exactly what to click on. So as you know, this is our administration phase. I really like the fact that it auto detects what restoration we're doing. So you're going to set this up the normal way. You're going to go, you're not going to change anything on there. You're going to just choose, am I going to do biocopy, am I going to do bio-individual or reference? And then you're going to look at the materials section. I have my materials that I standardly use in my office on there. Well, in this case, I'm going to now select a different manufacturer. So you're going to go down to the bottom there, and you're going to left click on select manufacturer. Once you do that, you're going to get a drop-down menu, and you're going to select Kuraray Nertaki. Underneath Kuraray Nertaki, you're now going to hit the down arrow. And on here, you can have a pop-up menu that gives you 4 options. Now, you remember earlier I was telling you about the CL block. The CL block is only going to be used on those top 2 choices, if you're going to grind it or if you're going to mill it. And that's a clear block because it's not a multi-layered. So for most of us, we're only going to be using the bottom 2. Are you going to be grinding or are you going to be milling? So for years, we thought we were milling chairside. In reality, with those diamonds, we were actually grinding. So if you're using diamonds, you're grinding. If you're using carbides, you're milling. So for all of mine in my office, I'm selecting the bottom of the KATANA Zirconia STML milling. So once I've got that, we're going to select the tooth or teeth that we're going to restore, and you put those in, and now you get the arrow forward. And now what you get to do is go into your next phase, which is the acquisition. You're going to scan in the acquisition phase the way you normally scan. You're going to do the V scan, you're going to do the C scan, you're going to do linear scanning, whatever technique that you feel most comfortable with. Remember, you need to scan approximately 5 to 7 teeth for the best BioJaw algorithm to work. Okay, so now we're in the next phase, the model axis phase. when we're setting the model axis, you want to set it ideally. So you're going to put it in the horseshoe. The second bicuspid goes in that last overlay, and you're going to line this up. And you're going to remember, docs, that you're looking at the curve of speed, curve of Wilson. You want to get that lined up underneath that line for a lower. You want to get that lined up for the, if it was above, if it was a maxillary, you would line it above. So what we have here is a situation where that's an ideal model axis, and then I'm going to go next. Okay, but instead of next, this is a very important part. You're not going to go into the model phase. I'm sorry, you're not going to go into marginate right here. You're going to actually stop, and you have to expand your step menu at the bottom of the screen. So right here, you're going to left click on those small black arrows right there, and watch what happens when you click on that. You've now expanded your thing to where you can go to the insertion axis. But before you do that, you've got to marginate. So once you marginate, you're going to go to your insertion axis, and it's a mandatory step for this block, because if you don't have the set right, it's not going to position well in the block, and it's going to be canted or lopsided, and you're going to be frustrated. So I always recommend that you set the insertion axis for any multi-layered block. So here's an example of the incorrect insertion axis on the left, which is actually what pulled up from that model axis that I set. And I had a really nice model axis, but that's what it looked like when my insertion axis, so I corrected it. So what you want to look at here is you want to have equal amounts of buccolingual and equal amounts of mesial distal. If you have that, that's going to position beautifully in the multi-layered block. So if you don't have a position, let's say you forgot and you did all this work designing, now you're going to mill, what you have on the left is what it's going to look like. That's canted, and that's actually not bad, but that's not acceptable to me. So I'm going to lose all my design, go back and change my insertion axis. So what I recommend is when you propose your restoration, you immediately go to the mill to see how it looks in your block. If it doesn't look right, change your insertion axis. Therefore, by doing so, you don't lose any design time. You're not doing double work. I hope that makes sense to you. So again, I'm going to repeat that. Once you set your insertion axis and you design your initial proposal, arrow forward, just like you do with a bridge, to make sure it fits in the block. You're going to look at it in the block. Does this fit in the block in the correct way that you want it? If not, reset your insertion axis, repropose. So I'm being told that in the next version of software, which is coming out in May, that this is going to be fixed. So I'm hopeful, but some of you are using it today, and I want to make sure you know how to fix this. So here's a situation where the insertion axis wasn't fixed properly. If you look, the sprue actually, because of the insertion axis being off, put the sprue on the occlusal surface. On the right-hand side, that's another restoration that was done that, again, if you see the layers, it's so canted on the right that I had to go back and reset the insertion axis. Everything was fine. So that was a lot of fun. A lot of fun to learn this. Not fun when it first happens. So let's continue on here. The design phase. So as we go into the design phase, there's not a lot of tricks here. Basically, you're going to go ahead and get your initial design, and as I just said a minute ago, you're going to now arrow forward, check your proposal, see how it fits in. If it fits right, you're going to just design to your desired thing. The only thing I want to make note of you right here is you want to go into activate your analyzing tools. Under analyzing tools, you want to activate cursor. You have to move your cursor out of the box, and it's going to activate your cursor details, which usually pops up on the lower left-hand corner. And you want to verify that your minimal fissure height is 1.0 millimeters or greater. Once you've done that, and you've set your proximal contacts and you've got your desired occlusion, you're ready to go to the next phase, which is our manufacture phase. So in the manufacture phase, what we're going to do here is there's a lot of steps here. There's a lot of moving parts. And the first one is I actually turn on my model. So I go to display options and I actually turn on my model. So it's a lower model if I'm doing a lower restoration, my upper model if I'm doing a maxillary restoration. So I like to do that because I want to just compare what I have in there. You don't have to do that, but I tend to turn my model on. It's just made it very easy if I'm going to put something at a line angle. I want to make sure I'm not hitting the adjacent tooth. I want to get an ideal sprue placement. All those things are important. So once you've done that, you're going to go to the first step. What I'm going to recommend, I do it in this order. I go to the bottom and I select my block size. This is absolutely important. With 4.50 and now 4.52, the restoration defaults to the smallest block size that it will fit into. Well, again, I just told you earlier 2 times, now I'm going to say the third time, 95% to 99% of your restoration is going to fit into a 12Z block. So if you only buy 14s, you have to go in and manually change that, because if not, you're going to get an error. And I'll talk about that in our troubleshooting section. So what we have here is you're going to select the 12Z. So you see I've got 12Z selected. So that's step number 1 in our manufacturer phase. Now we're going to go to step 2. I'm going to move my sprue. I want to idealize my sprue. Well, now on the posterior and the molars, it's going to give us one really nice thick sprue. Sometimes on the bicuspid there's 1 or 3, and the anterior is going to be 3. But you can position that so where it's not directly on the straight mesial or it's not on the straight distal. You can actually position it to line angles to where it requires less time to finish this case and to seat this case. So now you're going to select your sprue. You can do it under Tools, or you can right click, and I'm going to move my sprue to the ideal location. Now I've got my sprue where I want it, and now I'm going to my next step, which is moving the block. This is a step that I'm going to, this is the next to the last step that I'm going to do. I'm going to move it up or down based on my desired translucency, incisal translucency, or my desired chroma, or value that I want to have with my cervical. So it has 4 layers there. And I got to tell you, for the posterior, the 12Z gives me a great gradation, an ideal. The 14 has almost too much space between those. And a lot of times, if I mill this with a 14Z, I'm only getting 3 of the layers. So you want to be very mindful of that. So again, I think you're going to be using 12Z a lot more than you are 14Z. Nothing wrong with 14Z. It works great. It's just different applications. There's longer teeth, some of those anteriors. So now I'm going to move it up or down. I'm going to position it. I'm going to actually look at a photo that I take in the mouth, or I'm going to visually look and say how much incisal translucency. I'm going to set that. Maybe get the transition layer 1 to be right at the fissure so I don't have to characterize that. Those are nice little tricks and pearls. And now I've got my final desired thing by being able to position this. Now my understanding is in the next version, this is where you're going to be able to rotate this in the block as well to correct that cant that we were talking about. So then the insertion axis will not be a mandatory step. You can actually correct it here. But for as of now, as of April, you've got to make sure that you correct that insertion axis. So now our final step going forward is we're now going to go into our manufacturing export mode, and we're going to verify that the SpeedFire oven is on, because if you don't have it on, you're going to get a warning message, and if you still mill it, then you've just wasted a block because it will not transfer to your SpeedFire. But you're also going to select your mode. Are you going to fine or fast mill? Okay, so we find that the fast milling on this works. It works really well, but it's also dependent on your margin configuration. The fine mill on average is between 15 minutes and 19 minutes in my office. It's worked out very, very well. So I've done both ways, and I've seen no difference in my margins. So now you're going to hit Start Manufacture. So now we're ready to rock and roll and get this thing going. So I'm going to hit the Start Manufacture button, and now you're going to be prompted to scan the barcode. Well, I don't know about you, but my barcode scanner has never worked. So that means you're going to manually input. No disrespect to Dentsply Sirona. I don't know if they're working on it, but I'm told they're no longer selling machines that even have that. So you're going to punch in the code. So as you're manually inputting the code, that asterisk sign is defaulted down there. As you start to put it in, a lot of times as you're putting it in and you're rather rushed, you're going to start to put the code in and it disappears. So you got to make sure you're watching as you put the code in, and you want to make sure that you're going to have 7 digits, numbers, or symbols. Okay, so this is a very important point here. You're going to manually input the barcode, but you got to know that you need at least 7 numbers, letters, or symbols, a combination of those. Some of the blocks that have been issued only have 6, and we're going to go over that in troubleshooting. So just that's a big one. If you do get that block and you only have 6, not including the asterisk sign, then you just hit the space bar and then you hit enter, and it will actually mill for you. So we got those in there. So on this one, you've got a combination. That last symbol is the plus symbol, so that actually counts. So you have 7 up there. You're not counting the asterisk. And then you're going to hit start. Once you hit start, it's going to ask you to take the block. It's actually telling you the block that you selected, and you're going to put it into the milling unit, and you're going to hit start from the milling unit, or you're going to hit start from your acquisition unit, depending on how you like to do it in your office. So we're hitting start, and now we're going to start our milling process. Now, one of the funny things that we've uncovered is if I selected a 14Z and I put a 12Z block in, and I put the code in, and I hit start, it will actually give me a warning message, which we'll go through in troubleshooting. It will actually mill that block, but it will not transfer to the SpeedFire. So that's another glitch that you got to be careful of. So make sure you're always selecting the block in which you have stocked in your office, and you put the right block in. Okay, we talked about milling times. You can mill a 12Z or a 14Z. The milling time is only seconds difference between milling those. So you're not going to speed up the process by staying with just 12Zs, and you're not, the 14Zs are, I believe, $1 more per block. So you can fast mill like we talked about. So basically you have options and choices for how you want this to work in your office. And I like the fact that we have options. So let's go through some troubleshooting. This has been a lot of fun working on the troubleshooting. The important thing here is, this is the big one that I found early on, is that we were missing a digit here. If you count there, not including the little asterisk sign, there's only 6 digits or letters or symbols there. And I put it in, I hit enter, and nothing happened. I put it in again, hit enter, nothing happened. And so I realized that we needed to use a space bar after the number 1 there. So if you enter a space bar after you enter 1 and then you enter, it will mill it perfectly. This has been reported back to Dentin Sirconia. They're aware of it, and I will tell you some of the blocks that have been shipped recently still have that on there. So be very mindful of this. You will run into this. Here's the other one. You've got F224, is that a 0 or an O? 1, is that a 0 or an O? Well, in this case, if you want to take a screenshot of this, the larger O or 0 is a number, and the smaller one is a letter. I like that. But when you first see that and you're in a hurry, you're going to put them in the same, and it's not going to accept it, and you're going to think you have a defective block. Again, here, is that an O, or is a number, or a letter? So I would say always start with guessing that it is a number, and then try a letter if the number doesn't work. Some of the newer blocks, which I'll show you here in just a moment, actually have a line through that O or 0, showing you that it's actually a number. So that's exactly it. I just got ahead of myself here. So if you look there, the F22502Q, there's no misunderstanding there. But if you look below it, that actually is the number 0. So there's not consistency with the lettering system, the barcode system through Dentin Sirconia, and I don't know the answer why, but I will tell you that you're going to run into this. So if you can be mindful of this and always put it in as a number first and then do it, but this one is really baffling me as to why. But it doesn't really matter why. What matters is how can you make it work, and this is how you make it work. This is a barcode issue that we ran across. We did some testing. And these are the block shades. These are 12Zs, size 12Z blocks, and finding, is the number a 0, but it doesn't have a slash to it. There's 1, 2, 3, 4 blocks that have a dot at the end, and if you don't look close enough, you're not going to see that. It's a period. If you don't put the period in, it's not going to allow you to mill this. So when you're talking with your staff and they're inputting these blocks, you got to make sure they put that period in at the end. So again, this is stuff that we ran through in my office, so I know if we're doing it, you're certainly going to do it as well, because we're just like you. Okay, so here's a really interesting milling error. This has popped up twice in our office, and I know that in talking with some of the field reps and also talking with technical with Kuraray, this has popped up at least 4 or 5 times in the last 2 weeks, where it says no quality label is recognized on the block. The grinding and milling processes and these are specially verified for certified materials. So basically when I read this, it's saying I'm not using a certified material. And then it asks you a question: do you want to continue, or do you want to start the milling process? If you answer yes to this, it will mill the block. The problem is it will not send it to the SpeedFire. This, in my opinion, is a incorrect milling message, error message from Dentin Sirconia. Essentially, you get this when you select a 12Z, but you put a you select a 14Z, but you put a 12Z in the milling unit. So again, it occurs when you select the wrong block. It's the same manufacturer, but you're selecting the wrong block size. What this should tell you is you have the wrong block size, but for some reason it's not telling us that. And so please do not answer yes on that. Just answer no when you get that message, and you will get it at least once. And then what you're going to do is select no, and then go make sure that you change your block size from a 14 down to a 12 because you put a 12 into your milling unit. So I hope that one helps you. That one stumped me for a while. And then here's another one. This one popped up to me on a couple times. This is no furnace detected. milk furnace device was detected. Do you want to do the production anyway? I answered yes, because man, I'm in a hurry. I want to get this going, right? I'm ready to show the patient what I'm doing. And it mills, and this one will not send you the SpeedFire. This occurs when your SpeedFire is turned off, so you haven't turned it on yet, so it has no way of sending it to it over there. Or you need to refresh your devices under configuration because there's a conflict, and it will actually then recognize it. So at this point you should hit no, make sure your SpeedFire is talking to your acquisition unit, and then go ahead and go through the process of re-putting the barcode in, and then manufacture your KATANA STML block. Because if you do it any other way, it's not going to go to your SpeedFire. You just wasted a block, and now you're going to be 20 minutes plus, maybe a half an hour behind, because it's going to take you a while to figure out what just happened. Milling process complete. The restoration was not forwarded to the CEREC SpeedFire because the chosen block does not have a quality label. So this is what's going to pop up if you say yes to any of those two answers there. So make sure that you don't waste a block here. So please make sure you look at this and that you follow this as well. So this can happen when you selected a 14Z when you put a 12Z in, and also it's not going to forward to a SpeedFire if you didn't have the SpeedFire active. Okay, so when you're going to mill, how do we mill? You know, it's interesting to look at all these, and I've milled these, dry milled, I've wet milled, I've wet milled with just distilled water, I've wet milled with distilled water and lubricant, and I've wet milled with contaminated water. And I got to tell you, these do look different, very, very different. And so they meaning Kuraray and Nartaki's stance is they would prefer you to dry mill this. You can certainly wet mill this, but there's things that you have to do to make sure you ensure success. And so we're going to go through this. So when you dry mill, on your left motor, you're going to have the shaper 25. The finisher is a 10. Okay? So that's true milling. You're going to mill with these. And I do a lot of dry milling with this. I've also wet milled. This is the one. I have the unit that actually has the suction, so it's the wet dry mill. So again, you need the shaper. So if you're going to wet mill, you want the shaper 25 RZ and the finisher 10. So that's the difference of your required carbides for wet milling versus dry milling. Now you can wet grind, and that would be different diamonds on there as well. So if you're going to wet mill, the key points is you cannot use your water reservoir that is contaminated with silica-based ceramics, which is everything else you use in your office, whether it be the polyceramics, whether it be the, including enamic, or the Vita products like Trilux Forte, or you've got Empress, or you have Emax, Celtra Duo, all of these blocks that people are trying and using. If you have that in your water reservoir, you are not to mill a zirconia restoration with that, because it contaminated and will come out very, very awful. It'll come out just, and I have some photos that I can actually share online, which I'll do at another time to show you the comparison of all the ways you can do this. So you're going to have to, if you're going to be wet milling this, you have to wipe out your chamber. You're going to have to actually drain your water, clean the filter, flush everything, and then fill it with new water, fresh distilled water. And you're going to choose to do it with distilled water only or with lubricant. My recommendation to you, and this is my recommendation, not Kuraray or Nartaki, is to do it with distilled water only. So you're going to clean the filter. I got ahead of myself here, and you're going to fill with distilled water only. Again, this is my recommendation, and this is from my testing and my working with the product over the last several months since August. And so for me, it's easier just to change the reservoirs out. Take out the one that's contaminated, wipe out the chamber, and just put in a second chamber. And that's what I do. And my friend Daniel Vasquez, that's what he does in his office. And he has one labeled for zirconia, he has the other one labeled for all other products. And I think that's a really wise thing to do, because changing the burrs out from what you're milling Emax with or grinding Emax with, or Celtra Duo, or your flavor of the day, whatever it is that you're using, and then going to your zirconia, it takes a few minutes. But to wipe the chamber and to clean the reservoir out and to clean that filter is not a 1 or 2 minute thing. In our office, it's about 15 minutes. So I'd rather just have everything easier. I want to make it easier for my staff. I want to be more efficient and productive with that. Okay, so one of the things that you noticed when we were setting this case up is that nowhere did it ask you what shade of zirconia you're using for the KATANA STML. And that really threw me for a loop when I first started testing this material and working with it, is because I was so used to saying, okay, I'm going to select an A2 or I'm going to select an A3, and then my sintering time in the SpeedFire was shorter or longer. The darker the shade, the longer the sintering was. And so that really threw me for a loop, and I kept saying, I'm missing a spot here, there's something missing in the software. But again, in their R&D, what they decided was they're going to go with a 30-minute sintering cycle for all shades of their product, and that's what's working very, very well. So they have that consistency with their product. Also keep in mind the powder that I mentioned earlier in this webinar is the reason for that. It's a proprietary powder, it has a higher firing temperature, and you get more translucency with it. So this is a completely different beast than any of the other products that you've been using. So again, what I do is I select in the posterior one shade darker. I shade shift to the right, so if I want an A2, I do an A3, and I know if we base it on value, I'm not going to, it's actually different than that, but currently in the products that I've been using, that's how I've done it, and I'm getting a really nice match with my adjacent tooth. In the anterior, I'm finding that I'm actually using the same shade as desired because it's actually thinner material there, less reduction. So that's a good rule of thumb to follow there. Let's go forward. So again, we talked about the insertion axis. That's where my sprue, it's an example earlier where my sprue was starting to go up on the occlusal surface. If you look at the block gradation on the left, if you look at the multi-layers, you'll see that that was canted. So that was a good model axis that I had set, but the insertion axis, when it showed, when I went back to look at it, was off. So again, until the next version of software comes out, the version that's going to be after 4.52, you want to go ahead and set your insertion axis like I discussed with you earlier. So that's on the right, is it corrected after I redid the insertion axis. So now we've milled this restoration, we've got it out, and what I kept running into is how do I keep this from purling? How do, like if I over polish it, you know, because if you keep this in any area too long, it's going to turn pearly, and I want this to look more lifelike, more natural. So what I did is I came up with a pre-sintering technique using the right tool for the right job. And this 5 minutes of time is saving me so much time on the back end. And again, this is what I worked with. I worked with two outstanding ceramicists, master technicians. There's John Chia and Sean Hahn. And I learned so much from these guys on how to handle this because they've been working with this product since its inception in the lab. And I got to tell you, using the right tool for the right job has made such a difference on how I approach the finishing of this and when I finish it and getting the desired outcome for my patient. So again, this is right out of the sintering coming out. I pre-polished on the left. I've got a really nice, so I'm spinning all my work in the green state, which is softer, and this is what it's looking like coming out of the SpeedFire oven. I have very little to no work to do on this restoration to deliver it clinically. So using the right tool for the right job, this is where I position the block where I had transition layer 1, which is underneath the enamel layer, starting right in my fissure. There's no characterization on there, that's just pre-polished. This is right out of the sintering oven. So I like the fact that I have a lot of control over it, so I'm not having to spend a lot of time trying to make something look good. There's no reason to infiltrate these products, by the way, because it's actually a multi-layered, a polychromatic. You've got the layers already built into it, so you don't need to work and try to make something look better when it really doesn't. You have a block that actually can give you a desired outcome with very little effort. So we've got pore surface preparation, a lot of training with the others. Zirconias that I've seen around the country is that people say just remove the sprue, turn it upside down and center it, and then you're going to take care of it afterwards. But if you look at all four of these are all the same shade, the three in the back and the one in the front. The one in the front is the CEREC zirconia, same shade, but they're not pre-polished. They were just the sprue removed and put into the sintering oven. You can see quite a difference, but the surface texture is way too rough there for my liking, and when I go in to try to polish this after the fact, it's a much harder material, and I think it's a little more difficult to polish. And you've got to keep in mind that when you polish zirconia, you've got to use low RPM. You never want to go more than 4,000 RPM, and you have to use light pressure, and you constantly have to be moving on it, and if you don't, it's going to pearl so quickly, and then it looks really, in my opinion, quite bad. So what I do is I came up with a kit. I developed a kit in conjunction with Sean Hahn. We worked on this, and this is the GC07. I'm not trying to sell you this kit. This is just the kit I use that I can use for pre-sintering and for to polish post-sinter if I want. I've done a lot of work with Meisinger on their twist polishers, helping to develop those, and this kit just takes you soup to nuts on how to remove the sprue. So you never want to just tap the sprue off like some people were taught. You actually want to use, I use a lab carbide, and then that same thing I can now use to accentuate any anatomy if needed, and that's not all the time, it's maybe 10% of the time. And then I go through a series of polishing points in those twists and buff it off, and then I'm ready to actually, when it comes out of the oven, it looks like that picture I showed you before. So this kit is available through your Shine rep, through your Patterson rep. You can also contact Meisinger as the GC07. Just so you know, I received no financial compensation on the sale of these kits. So I want to be very clear on that. But I do like this product a tremendous amount. So again, this is what we get coming out of the oven. We've got great surface texture. It's not porous. It's pre-polished. If I want to apply glaze, or if I just want to hit it with my twist and then get ready to bond this in, I can do that. So I save so much time on the back end from doing that 5 minutes before I put it into the oven. Again, here's some other examples. So if I get it out of the oven and I've sintered it, and now I just want to go ahead and polish it, I'll use the yellow twist polisher, again 4,000 RPM, and I'll set it on there. But you got to be careful that it doesn't become pearly, so you got to constantly be moving it. You can't leave it in the same spot. Many of us were trained to use a great product called Diashine, and we use high RPM and we use a lot of pressure and generate a lot of heat. You can't do that with you cannot do that with zirconia. So be careful trying to treat this like you treat the lithium disilicates, the lithium silicates, and the polyceramics, as well as just the feldspathics, because it does handle very, very different. And what you want to look at here is look at the shift in color here, look at the chroma, look at the value. You've got a nice looking surface texture on this with minimal effort. So one of the techniques that I came up with Sean Han was, why don't we polish our contact points and glaze the rest? So what we did is we spent a few minutes on just polishing where this tooth was going to be occluding in the mouth, and then we're going to glaze the rest. And yes, you can do that, but I will tell you it takes some time and energy, and for me that was really hard. So what I do is when I glaze, I will actually then go in the mouth, adjust my contacts, and then polish those contacts. So all my occlusal contacts are always polished, not glazed, and any part of the restoration that's touching tissue is going to be polished as well. We get great attachment with that tissue to the zirconia. It really does quite well with that. So I think that's very, very important. So the other thing that's important that I want to share with you is whatever glaze you use, you want to make sure that glaze has the same thermal coefficient of expansion as the material you're putting it on. And so one of the things I like about the CZR glaze is that it was actually developed to be used with this product. And so it's so completely biocompatible, and it's a great product to work with. When you glaze, you don't get a pearly effect as well. So I actually glaze and polish on each restoration. Some people don't want to do that, I understand, but for me, it just works very, very well. So when you're applying your glaze for a zirconia restoration, this is a very, very key point. Do you sandblast the external surface of the restoration? And yes, I said external surface. And the answer to that is absolutely. You are going to sandblast that, and then you're going to clean it in the ultrasound or steam it, and then you're going to apply your glaze. And what you've got to make sure when you're doing this is you want to make sure that the glaze is observing, meaning that it's not running off. And so I like to use this product. Again, CZR is especially manufactured for zirconia. This is a Kuraray Nortaki product. And currently it is only available through Shine and Zon. And so this is a product that has just allowed me to do some really great things. The kit on the bottom is basically an intro kit, and I have the kit on the top. And I will tell you, for Chairside, the kit on the bottom is probably all you're going to need. So less is more when you're looking to spend money on something that's going to work for you. So again, does it observe? We're going to place the glaze on here, and we're going to do a nice thin layer on this. It's observing quite well. It's not running off. If it is running off, then you would go back and sandblast again and clean that up. Then I'm going to do some slight characterization there to my desired way. I use an endo file, and then I cut or feather through. I'm not trying to create a tobacco look or a coffee look. I'm just trying to accentuate an illusion of depth. And these are 3 restorations that I did with the CZR. using different components, different clear glaze. I'm using the regular glaze, and I'm using the fluoro glaze as well, with some a little bit different on the occlusal surface as well. And I think you can get some pretty outstanding results that are very natural and lifelike. Okay, so let's go to our final section here. How do you bond to zirconia? I'm amazed. I'm on several groups on Facebook, and everyone is saying that you just cannot bond to zirconia. And in fact, the research for the past 20 years is showing that you absolutely can bond to zirconia. And there's a, I believe it's this month or next month in the Journal of Prosthetic Dentistry, there's an article showing that the bonding to zirconia is equivalent to that of bonding to Emax. So I think there's just some fantastic research out there that supports this. And if you have more questions on this bonding and want to capture the research, contacting Kuraray and Otaki, their technical department, they can assist you with that information as well. But there's really only 3 requirements for bonding to zirconia. You've got to sandblast or micro etch the internal of the restoration. You've got to clean the internal of the restoration, and you're going to apply MDP for chemical bonding. And keep in mind the MDP, which is in a lot of products that we use, not all MDP is the same, and we should probably broach that here in just a few minutes. So the first step you're going to do after you've tried in the restoration is you're going to micro etch the restoration. So what you're going to do is 30 to 50 micron aluminum oxide powder. There are some research showing that if you do the cojet, it's even a better situation than this. So there's some research pointing to that as well. But you're going to do 15 psi to 58 psi. Now, it's very important, doctors, to let your assistants know that they will not see a change in the surface of that restoration. They're going to look for, hey, like when you etch it with if you over etch it with, not zirconia, but if you over etch a feldspathic with hydrofluoric acid, it's going to look really white and chalky. You're not going to see anything like this. It's going to look just like when they first started. And so it's very important to understand that they're not going to see a change in the surface. So the first step, after you try it in, now you're getting ready for your cementation protocol, or your bonding protocol, sorry, you're going to go ahead and do your micro etching. So again, 30 to 50 micron size, 15 to 58 psi, which I believe is 2 bars, and you're not going to see a change surface. Then you're going to actually clean it. Okay, so you're going to put it in a little small ultrasonic cleaning that are reasonably cheap. You can put it in with ethanol, or you can steam clean it, which works really well. Or a lot of people are using a sodium hydroxide based cleaning agent. Okay, you'll put that on, and that does a really great job of cleaning it out as well. Okay, so Dr. Blatz, Marcus Blatz, has done a fantastic article. He's at the University of Pennsylvania, and his APC technique is the technique that I actually use in my office daily. And so again, that article is readily available as well. But his technique is to me is the gold standard on bonding in zirconia. Okay, so now we've got it cleaned, and now we've got to say how are we going to put this on here. We're talking about MDP, we're talking about, I use PANAVIA V5, some people use PANAVIA SA, some people are going to use Verilink Aesthetic, some people are going to, whatever you want to use. But the key to me is I want to have the highest initial bond strength, and I also want to have the highest bond strength at 24 hours. Why do I want the highest initial bond strength? Because we adjust our occlusion after we seat the restoration. And so I don't want to create any micro chattering or problems that's going to affect that bond. So if I've done IDS, I'm going to have a greater bond strength, or if I haven't done IDS, I still have the NDP that's going to go on there, and it's going to help create the bond that we need on here to have incredible bond strengths for zirconia. So if you look and you have a crown come off that maybe you got from the lab, and the cement's all on the tooth and nothing's on the crown, you didn't actually prepare the surface of the zirconia properly. So with MDP, it's a 10 carbon chain thing. The key here is how it's synthesized, how pure it is, but more importantly, it's the catalyst that each company uses for this to bond. It's actually very difficult to cure MDP, and Kuraray and Otaki has some patents that are still in effect. They have the best catalyst to get the highest bond strength in the world on this. And so I stick with their CLEARFIL Ceramic Primer Plus when I'm working with this. Another alternative that some people use is the Monobond Plus. I wouldn't use any of the combination products. I just don't think that they're going to work as well as what I'm seeing with the chemistry on this. So I'm going to actually treat the inside of the restoration with CLEARFIL Ceramic Primer Plus. The beautiful thing about this product is you put it on, it instantly activates. You don't have to scrub it on for 20 seconds and then wait 60 seconds and then air dry off the excess. You put it on, you can now dry it off, you're ready to rock and roll with this. So there's another time-saving pearl for you as well. Then you've got all these 5 different cements you can use. You can use the PANAVIA SA cements, which work very, very well for this. You got the 2.0, which some people live and breathe by. I just happen to be the person that really enjoys using the PANAVIA V5 in my hands. It's got such an easy cleanup. So the article I mentioned to you earlier was how to bond to zirconia. It's the APC technique. It's Dr. Marcus Blatz. I hope to one day spend some time with him. He is probably in this country the top, or one of the top 2 on research with zirconia, and his research that he did overseas before coming here is pretty exceptional as well. So using the right tool for the right job. People say that your bond strengths are going to be lost after 1 year, 2 year, 3 year. The reality is that the research, even with the cantilever Maryland bridges that were zirconia, are now have 10 years with a 96% success rate, and 3 of them that failed were due to trauma. So, you know, you're looking at some real interesting things here with zirconia. There's so much misinformation about there that you can't bond to it. So the reason I'm bringing this up is that Kuraray Nataki recommends that you bond the restoration instead of using a glass ionomer, a resin-modified glass ionomer. And they just are trying to, because they have the products that are probably the best products in the world for bonding, they have complete faith in being able to do this. Now, we know that 70% of the market is a resin-modified glass ionomer, but now you just have another option to get this in to ensure a greater success in your clinical environment for your patients. Okay, so for more information on this webinar, you can contact Kuraray Nataki. There's a couple ways. First one is emailing the katana.blocks@kuraray.com. That's if you want to have some direct communication, or if you want to have more information about the blocks themselves, there is a website located here. That's www.katanablocks.us. And so my name is Dr. Greg Campbell, and I was very, very pleased to be able to present this information to you. And if you have any questions, feel free to reach out to me also through Kuraray Nataki. Thanks, and I hope you have a wonderful day.